Hello friends, today is our 8th lecture of design of transmission lines and distribution lines. In this video, we will talk about nominal voltage and rated voltage, how to calculate phase-to-phase distance of power lines, phase to ground vertical clearance of power lines, phase to ground horizontal clearance of power lines. Before starting the lecture, please subscribe the channel, like and share the video on your social media profiles. This is the nameplate of potential transformer. You can see here that it has two voltage ratings. One is NSV and another is HSV. NSV means nominal system voltage, which is 33 kV, and HSV means highest system voltage, that is 36 kilovolt. HSV is also called the rated voltage. This is the nameplate of current transformer. You can see it has also two voltage ratings. One is NSV, that is 33 kV, and another is HSV, that is rated voltage, that is 36 kilovolt. Now we will see the definitions of nominal voltage and the rated voltage. Nominal voltage is defined as the voltage value of electrical equipment for which it is designed to be used is called the nominal voltage. That means nominal voltage means the voltage level up to which the equipment can be used. The rated voltage is defined as the maximum voltage that can be applied to equipment safely is called the rated voltage. That means rated voltage is the voltage level up to which the equipment can bear safely, that is, it does not get damaged. The nominal voltage and their rated voltage of various power lines are: for 11 kV, the rated voltage is 12 kilovolt. For 33 kV, the rated voltage is 36 kilovolt. And for 66 kilovolt power line, the rated voltage is 72.5. And for 132 kV it is 145 kilovolt, and for 220 it is 245 kilovolt, and for 400 kV it is 420 kilovolt. For 765 it is 800 kilovolt. To prevent the power line outage due to weather conditions like snow, wind and extreme temperatures, proper clearance between phase to phase and phase to ground is needed. First of all, we will see the phase to phase clearance. What does the phase to phase clearance mean? We have three phases R, Y, B. The distance between these two phases is called the phase to phase clearance, and similarly the distance between Y and B is called the phase to phase clearance. The formula to calculate the distance between phase to phase in transmission lines as per IS 5613 Part 1 Section 1st 1985 is D equals 500 plus 18U plus L square divided by 50, where D is the phase to phase distance in mm and U is the line to line voltage in kilovolt and L is the span in meters. The another formula to calculate the phase to phase distance is S is equal to under root of D plus V divided by 150, where S is in meters, V is the voltage in kilovolt and D is sag in meters. Now we will calculate the phase to phase clearance of a 11 kV line with span 40 meters. D is equal to 500, this is from formula, and plus 18 is also a formula, and U is the line to line voltage in kilovolt. For 11 kV the line to line voltage is 11 plus the span is 40 meters, so L is equal to 40 square divided by 50, it is 730 mm. It is the minimum distance, but you have to keep distance more than that, taking safety factor into consideration. D equals 1.46 into D. D is the minimum distance, and it equals 1.46. Here it is not 5, it is 6, it is by mistake. It is 1.46 into 730, that is 1065.8 mm. That means the phase-to-phase clearance of 11 kV line with 40 meter of span is 1065.8 mm. The phase-to-phase clearance of various transmission lines is, for LT lines we have two arrangements. One is vertical arrangement and another is horizontal arrangement. For vertical arrangement, the phase-to-phase clearance is 300 mm, and for horizontal arrangement it is 450 mm. Similarly, for 11 kV it is 1070 mm. Similarly, for 33 kV it is 1525 mm. For 66 kV it is 3100 mm, and for 132 kV it is 8200 mm, and for 220 kV it is 10300 mm, and for 400 kV it is 12800 mm, and for 765 kV it is 15,000 mm. Now we will see the phase to ground vertical clearance of transmission line. This is a transmission line. This is the conductor of a transmission line, that is called the phase of the transmission line. The vertical clearance from the ground is the phase to ground clearance. The thumb rule for vertical clearance along the roads or highways is H is equal to 5.2 plus 0.3 for every additional kilovolt above 33 kV. For above 33 kV, for every additional 33 kV, you have to keep the distance of 0.3 0.3 meters. The phase to ground clearance of various transmission lines is, for LT line it is 5.5 meters across the road or highways, and across the railways it is 15.6 meters. Similarly, for 11 kV it is 6 meters across the road and highways, and across the railways it is 15.6 meters. For 66 kV it is 9 meters, and across the railways it is 15.6 meters. For 220 kV line it is 9 meters across the road and highways, and across the railways it is 15.6 meters. For 400 kV line it is 9 meters, and for across the railway it is 18 meters, and for 765 kV transmission line across the road or highways it is 12 meters, and across the railways it is 24 meters. Now we will see the phase to ground vertical horizontal clearance. This was the vertical clearance. Now we will see the horizontal clearance. This is the clearance, horizontal clearance, phase to ground horizontal clearance. This is the building, and the distance of a transmission line from the corner of the building is called the phase to ground horizontal clearance. This is the transmission line and this is building. This distance is called the minimum horizontal distance. The thumb rule for this is D equals 2 plus 0.3 for every additional kilovolt above 33 kV. For above 33 kV, for every addition of 33 kV, you have to add 0.3 meters for horizontal clearance. The phase to ground clearance of various transmission lines are, for LT line it is 1.2, for 11 kV it is 1.3, for 33 kV it is 1.5, for 66 kV it is 2.3, for 132 kV line it is 2.9, and for 220 kV line it is 3.8 meters, and for 400 kV line it is 5.6 meters, and for 765 kV line it is 10.2 meters. Now I will show you how you can calculate the phase to ground, that is horizontal clearance of any transmission line. Suppose we have to calculate the phase to ground horizontal clearance of 132 kV line. D is equals 2 plus 0.3. This is a formula for every additional kilovolt above 33 kV. We have to add 0.3 meters. So we can add 2 plus 0.3 into 132 kV, 132 minus 33. D equals 2 plus 0.3 into 3, that is D is equal to 2 plus 0.9, that is 2.9 meters. Same is here mentioned for 132 kV, the phase to ground horizontal clearance is 2.9 meters. Thank you.